God, the universe sure is magnificent, huh? All the planets, the stars, how they all work so perfectly synchronized, but how does that work? How do black holes work? How does anything work? Well, I'm here to answer most of those questions. Mostly, how do black holes work? So, you probably already know what a black hole looks like, but maybe you just don't understand what's going on. So, let's try to break down the picture and maybe we can understand the concept of a black hole a little easier. Now, if you're disappointed by that picture, well then I think you're missing the gravity of the issue at hand. See, Einstein made a lot of theories and propositions of how general relativity and time was gonna work near a black hole, and thanks to that picture, we know he's right. So it's very interesting to know that he was on point with all that. Now, let's try to break down the heart of a black hole. That's called the event horizon. So there's no going back from this point, and even light gets consumed. So there it is. It's at the heart of a black hole, and that's what it represents. Now, there's also another ring that surrounds the black hole. So that other ring that surrounds the event horizon is called the accretion disk. And in that disk, there's dust and gas swirling around. It's extremely hot. We're talking millions of degrees. And it's going so fast that it's a fraction of the speed of light. So it is turning into plasma as it surrounds the black hole. And this is the mass from which the event horizon feeds off. Now, you may be asking yourself, well, why doesn't that matter go all the way into the event horizon? Well, there's actually a stable ring right around the event horizon in which if anything gets a little closer, it just immediately gets consumed.
Nice.
By the actual event horizon. Now, there's something that can actually orbit closer to the event horizon than matter itself. That something closer would be light. And as you can see, I placed a little ring around there that represents that photon ring, or light. And the reason it's actually able to get closer is because it has no mass. Now, if you were to be standing there, which obviously you wouldn't be able to, you'd get spaghettified. You would actually be able to see the back of your head because the photon rays would go around and loop as they would in a black hole. So that's why it looks very, very strange. Oh, hey, I didn't see either. I'm gonna talk about today's sponsor, Nord Quantum Mechanics. Well, what are quantum mechanics? Well, I wish you didn't ask me that question. But seriously, what are quantum mechanics? Well, we don't know. And the fact that we actually try to understand what they are is very, very amusing. Let's pretend that we actually know what we're talking about. Well, then maybe then we would be able to give you a job and, maybe a stable income. But that doesn't exist, just like quantum mechanics. It's all theoretical. And maybe you've heard of the cat, the magical Schrodinger's cat. Well, that still doesn't mean anything because there are other thousands of theoretical propositions. And some people would say that I'm being pessimistic. And they're right. Why would you ever want to confuse yourself? If you ever want to unlearn everything you said, no, don't cut me out, please. What's unique about this photon ring is that unlike the accretion disk, it actually has an unstable orbit. So what happens is that as the photon rays, which is just light, approach the event horizon, they either get sucked up or they spin around and just go off into infinity. So why is that? Well, black holes actually warp space and space-time around them, which actually makes that weird geometric figure because light rays are no longer straight. Well, space-time isn't exactly straight, it's curved, but for argument's sake. Now, the best way to think about this is if parallel light rays are approaching the black hole from the actual satellite which we took the picture from. See, what will actually happen if we send parallel light rays into the event horizon, they'll just get consumed and we'll never see from them again. This continues happening. Even if a light ray goes through the photon sphere, it'll end up getting wrapped into the black hole and curves across the event horizon. Now, from those very same parallel light rays that we sent, we actually get this mapping of the event horizon. So as I said, because light rays bend backwards, you'll actually map out the event horizon onto this top part. It'll just keep happening infinitely around it. And I can show a picture And it kind of helps you understand how light rays are bent, even in the event horizon as we see it. This kind of help you understood what the components of a black hole are and why the picture looks that way. Now, by no means am I graduate, nor should you take what I said here as an absolute, because science changes and many of these theories might change as we get closer to black holes. But this is all just one way to try to get more people to try to understand black holes and see why they're just absolutely awesome. So, thank you. Bye-bye. Goodbye. Bye.